Hey everybody, this is Mrs. Mancuso, and this is our AP Bio practice FRQ for Friday, May 15th. So this is a typical type 1 question, which means that it's going to have 10 parts with 10 action verbs, and it's worth 10 points. It is 65% of your grade. You'll have 25 minutes to answer it and 5 minutes to upload it. And it's based on a lab. So one way to measure the rate of the enzyme catalase decomposition of hydrogen peroxide is to use an oxygen indicator. The indicator changes color from clear to brown with the presence of oxygen. The darker the color, the greater oxygen present. To quantify this color, to quantify this color change, a spectrometer could be used to measure the absorbance of light. All right, and then they show us the reaction. Hydrogen peroxide decomposed into water and oxygen gas. Student 1, a student tested the effect of the catalase enzyme on the reaction rate at different temperatures and different catalase concentrations. So here's her setup, all of her different temperatures and her different enzyme concentrations. And student 2, another student's data is shown in table 3. He fluctuated the concentrations of enzyme and substrate. All values shown indicate the light absorption in AU, absorbance units, gathered by a colorimeter probe. All right, so this kid's got a baseline, and then he used double the enzyme or half the enzyme, double the substrate or half the substrate. And it shows all the different readings. So on to the questions. Identify an independent variable in student 1's experiment. So the independent variable is the one thing that you change. So back up in the first experiment, the first student, she changed the temperature and she changed the enzyme concentration. So there's two possible choices: temperature or concentration of enzyme used. All right, explain why student 1 tested the catalase activity over a range of temperatures and not just a warm and a cold. Okay, so anytime you do something over a range, it is to gather more data points to better notice trends in the data. So for example, if she had only calculated the rate when it was really cold and really warm, the rate was extremely low then, but you had this big curve in the middle, you would have missed all of these points. So you do not want to miss changes in the rate if you skip large temperature intervals. Okay, next one. Explain how light absorption can be used to measure the rate of the reaction. Okay, so light absorption measures or quantifies changes in color. Low absorption is what you get when you have light colors. And high absorption is what you get when you have dark colors. So as the reaction produces oxygen, the indicator changes from light to dark. And so you can measure this change by the increase in absorption. The darker it gets, the more oxygen it was making. All right. Identify the ideal temperature of those tested for the decomposition. So I go back to that first experiment and I want to see which one is the most brown, because whichever one is the most brown is doing the most decomposition. So 43 degrees Celsius. All right, in the second student's experiment, identify the contents of the baseline. Okay, Let's go back to the second student. So here's the second student's work. Here's the baseline. Okay, so if you have 2 times the enzyme, let's just compare these numbers. You have a greater amount of decomposition that happened. And if you have half the enzyme, you have less than it. All right, so my baseline must have 1 times the enzyme. And then let's look at the same thing with the substrate. So I'm just seeing if it's a value in between the two, and it is. So that means I have 1 times the substrate in my baseline. So the baseline's like the normal. So 1 times the enzyme and 1 times the substrate. That would be my control, and that's how I will be able to judge how the difference is based on 2 times or a half of enzyme or substrate. All right, calculate the rate of the reaction for 2 times substrate from minute 1 to minute 4. All right, let's go back here. And let's see, here's 2 times the substrate. I want from minute 1 to minute 4. Okay. I already forgot that number, 0.298, 0.298, 0.80. Okay, so the rate is equal to the change in Y over the change in X. And so this absorbance, it would be my Y. And so it changed by this much, and 4 minute minus 1 minute. It's definitely going to be a positive answer because the amount of absorbance increased. So let me just grab a calculator quick. 0.298 minus 0.08 divided by 3 is equal to 0.073, and then it's absorbance units per minute. You always want to make sure that you have a unit there. So the absorbance went up by 0.073 per minute for 2 times the substrate. All right, predict what the absorbance of light in absorbance units would be for student 2's experiment using 1/2 the substrate at 6 minutes. Okay. Let me grab a different color here. 1/2 substrate. Here it is normal. And so let's see, it goes from 0.080 up to 0.139 to 0.198. That's a huge increase. Each of these are a big increase, to 0.27. And then it only increases to 0.287. So this is increasing by about 0.7. And this one is only increasing by 0.17. So that means if I only have half the substrate available, my graph has done this, and now it's starting to plateau. So I do not want to have it increase by more than 0.17. So 0.287, let's just say I have it increased by 0.1. So that would be, oh, sorry, I just did this wrong. 27.017, and here to here it's 0.07. Sorry, I apologize for that. So 0.01. So I'm going to say 0.297. That makes sense. 0.27, 0.287, 0.297. And now if you have a range that's acceptable, that would be great. I'm going to tell you right now that if you put like 0.35, not going to be accepted, way too high. All right, so go over to here. Oh, I already forgot what my number was. Sorry, guys. 297. Justify your prediction. So my justification is that the change from minute 4 to minute 5 was 0.017. Sorry, just got to look back here what I wrote. 17. So substrate is running out at this point in the experiment. So I expect less of an increase in O2 production. And so that is how I came up with my answer. I could go into further detail and say that the rate was high as the substrate and enzymes were colliding and producing oxygen, but that eventually, because there was only half the substrate available, it ran out of substrate available for the reaction. All right, identify another way to calculate the rate of this reaction. So in this reaction, they measured O2 production. I know for any experiment, if I want to calculate the rate, I want to calculate the change in reactant concentration or the change in product concentration. So specifically, I could measure the H2O2 decomposed per minute. Or I could also measure the water produced per minute. If I go back to the original formula, here's my formula. We measure, or the students measured this, but you also could measure the disappearance of this or the appearance of water. Okay, the enzyme catalase responsible for this reaction is found in all types of cells and is specifically located within peroxisomes of eukaryotic cells. Explain why the reaction is more efficient and effective in eukaryotic cells than in prokaryotic cells. Okay, so in a eukaryotic cell, reactions are compartmentalized. They love that word. By organelle. So this reaction has its own location peroxisomes where it occurs. In a prokaryotic cell, they don't have membrane-bound organelles. So this reaction would occur in the cytoplasm and be less efficient due to other reactions also occurring in the cytoplasm, which means you have a chance of having multiple reactants and multiple products in that area, as well as multiple enzymes in that area. You want to limit the reactants, the products, and the enzymes, and that is exactly what membrane-bound organelles do. So again, based on your time, you could go into more and more detail on that one. All right, thanks.